Hey guys, what's up everyone? How are you people doing? Welcome to today's session. Hoping that all of you guys are doing good. This is session number 4 for our refraction of light at plane surfaces. My name is Anoop and welcome back to yet another amazing session. Today we'll be talking about basically factors affecting the angle of deviation and refraction through a prism. Two very important topics which carries a lot of marks. So pay attention to everything that I'm saying, guys, and whatever doubts you have, let me know in the comment section as well. And before we get started, slap that like button, people. What are you doing? And also subscribe to the channel as well so that you are, up to date with whatever content is put up on this particular channel. I hope you guys are making the best out of the opportunity that you're getting out of this. Anyways, with that said, people, let us start off with a very simple quote, put our minds at ease, and then get started with today's session. So the quote for today is this: it takes nothing to join the crowd, it takes everything to stand alone. No, this is a very important thing, guys. I know that majority of you guys know this already, that all the great personalities in the world, you know them because they had the courage to stand on their own. They had the courage to stand alone, and all those who didn't are names that have been forgotten in history. So if you're someone who wants your name to be remembered, if you want people to talk about what all great things you've achieved, you have to have the guts, you have to have the courage to stand alone, no matter what that is. That's totally up to you. I'm not going to tell you, I'm not going to set the path for you, but I'm telling you that whatever you're doing, make sure that you're the best at it. Make sure that you are the one who's leading the crowd. All right. Anyways, with that said, people, let us start off with today's session, that is refraction through a prism and factors affecting the angle of deviation. But before we get started, guys, let me just quickly tell you what the homework was in the last session that I'd given you. The question was this: refractive index dash with increase in the temperature of the medium. I've told you this: if the temperature of the medium increases, then the speed of light increases. So the refractive index actually decreases because the speed of light is increasing. The refractive index actually decreases. It's indirectly proportional. So if temperature increases, refractive index is actually going down or is actually decreasing. So that is the answer, guys. Well done to all those guys who gave the right answer. Keep up the good work. With that said, let us now understand refraction through a prism and then work our way through what are the factors affecting the angle, the angle of deviation as well. So first of all, let me tell you what a prism is. This, my friends, is what a prism looks like. I'm pretty sure the majority of you guys know about it. I don't think I have to, actually, yes, sure, but I'm pretty sure that everyone knows about it by now. Now, to tell you a little bit about a prism has basically, it's a transparent medium. Obviously, light can pass through it, and it is about 5 different plane surfaces. All right, you have 5 plane surfaces, one on each side, front and back, and then the base as well. So you have the refracting surfaces again, which basically looks like 2 rectangles, and then you have also a base as well. Now if you were to cut a prism in half, the cross section would look basically like a triangle. So it's a triangular cross section because it basically looks more or less like a 3-dimensional triangle itself. So there's 2 rectangular surfaces which acts like the refracting surfaces, and then you also have the base as well. So that's how the prism basically works. So you have the light which falls on one side and then it is leaving from the next. So let's talk about how light refracts through a prism. Let me just tell you what does it look like and what are the factors that affects it as well. So starting with the first one, guys, imagine a ray of light, let's say PQ, is incidenting on this surface. So it's an inclined surface. The ray of light is coming and hitting the surface. Now the ray of light is actually going from a rarer medium into a denser medium, from air into glass. So in this case, what will happen, the ray of light would refract and it'll go towards the normal. So that's what you are seeing over here. You see this, the ray of light is actually moving towards the normal. So that's why after refraction, it's basically a straight line. But then again, it's not exactly, it's supposed to go like this. Apparently it's supposed to go like this, but then because of refraction, it's actually taking a different path. And this here is nothing but the normal. This is the normal, which is in 90 degrees to the inclined surface. So it's normal, 90 degrees to the surface. All right. Now, after refraction, the ray QR will go and incident on this surface. So this will be that ray QR will be the incident ray on the second surface. Now again, it'll refract because it's going from two different mediums. It's going from a denser medium into a rarer medium. So what you see is that the ray of light again gets refracted, and this time it'll try to go away from the normal, because I told you this, that when a ray of light is going from rarer to denser medium, it tries to move towards the normal, and from denser to rarer medium it tries to go away from the normal. And this ray has a different name, and this is called as the emergent ray. It's coming out of the prism, so it's called as the emergent ray. And this again would be the normal, and you see this is the normal, again 90 degrees to the surface, and this again would be the emergent ray. And when you extend both of them, they basically meet at this point. All right, so I'm just going to name this point as N. Just I'll tell you what is the purpose for it after that. All right, so I've gotten this. Now people, if I extend this incident ray, all right, and this emergent ray, all right, basically they'll meet at this point. Now the angle that is formed between them is called as the angle of deviation. This is by how much the ray of light has actually deviated from its original path. Now if you think about it, this here is one angle of deviation. This is you can call it as delta 1. That is the first time the ray of light is deviating, and this is delta 2. This is the second time the ray of light is actually deviating. So in total, you can say that sum of two interior angles would give you the exterior angle, or the exterior angle is equal to the sum of two opposite interior angles. So delta 1 plus delta 2 would give you basically delta, as simple as that. So in a prism, you have two inclined surfaces, and you have incident ray and an emergent ray. And this, in this case, unlike a glass slab, here the emergent ray and the incident ray is not going to be parallel to each other, because both the surfaces are inclined, so it's not going to be parallel. So don't come into the impression that this time also it's going to be parallel, the incident ray and the emergent ray is going to be parallel. No, it is actually not going to be parallel, because both the surfaces are actually inclined. So like I told you guys, so there's an angle formed between the incident ray and the refracted ray, or the emergent ray. This is called as the angle of incidence, or angle of deviation, sorry, and the way that it's denoted is by the letter delta. So delta is nothing but angle of deviation. Now this is the entire named, all these named different parts that I've named. So we'll call this point as T. This is the angle of refraction on the first surface, R1. This is the angle of refraction on the second surface. I would be the incident ray. You can call this as E, or we'll take it as I dash. All right, I dash would be the emergent ray, and this A is nothing but the angle of prism. That is the angle that is formed between LM and LN. That is nothing but angle of prism, which is also an important factor which we'll be looking into later. So these are the different parts. Now that you've understood this case, now let me just tell you some basic geometry before we actually do the derivation of how do you find out the angle of deviation. So in a quadrilateral, no matter which quadrilateral you take, the sum of all the four sides would give you 360 degrees. The sum of three sides in a triangle gives you 180 degrees, and the opposite sides are always equal. So angle 2 is equal to angle 4, angle 1 is equal to angle 3. In the same way, the sum of the exterior angle is equal to the sum of two opposite interior angles. So D is equal to A plus B as well. So these are some of the basic mathematics, basic geometry which you've seen in the past. So I'm going to take a prism. All right, I'm going to name all the parts. So this here is the angle of incidence. This is the angle of refraction, the emergent ray, sorry, which is I dash. R is the angle of refraction in the first surface, and R to R dash would be the refracted angle for the second surface. M is the meeting point of both the incident ray and the emergent ray. Delta is the angle of deviation, and A would be the angle of prism, or we'll just leave it as we'll just name it as ABC for now. All right, now what I'm going to do is that I want to do a small derivation. Alright, so everyone keep up with me. Now there's not enough space to write, so I'm just going to show you one step at a time. Now angle QMR, which is nothing but this angle QMR. Angle QMR is what? Angle QMR is equal to this angle MQR plus MRQ. All right, so again, this is the sum of two angles would give you the third angle. So here angle M, QMR is equal to angle MQR plus MRQ. Simple. Now, the angle of deviation. So I'm just going to remove this so that I can just show you one step at a time. Angle of deviation delta is equal to what? This angle plus this angle, right? I told you that the sum of two opposite angles will give me the exterior angle. So what is that? It's again MQR plus MRQ, right? MRQ plus MQR would again give me what is delta. Now, what is MQN? All right, let me just erase that. What is MQN? MQN is this angle. What is this angle? This angle is I. Why is it I? Because this is the angle of incidence. Opposite angle is going to be the same. So MQN is equal to I. Now MRN in the same way here, this is going to be I dash. Why I dash? Because again, it is the exterior angle. I mean, it is it's opposite angles. So that's also going to be the same. Now MQR, that is MQR, this angle here is basically equal to what this entire angle minus this angle minus this tiny angle minus this R, that will give me this angle, which is very, very obvious. So I'll get it as I minus R. In the same way over here also, what is MRN? MRQ. MRQ is what? This entire angle, which is I dash minus R dash, that will give me what is MRQ. Now, what is delta? I'm going to substitute these two values in this equation. All right. So delta is what? I minus R plus I dash minus R dash. All right. Very simple. Now I'm going to remove these negative signs and rearrange the equation to group all the I terms and to group all the R terms. All right. So both of them have negative terms. I'm going to take that outside and I'm going to rearrange the term to give me I and I dash. So I plus I dash and R minus whole of R plus R dash. Very, very simple. All right. I hope you guys understood so far. Now, if you talk about this quadrilateral, that is AQNR. What is that? AQNR. This quadrilateral. Right? This entire quadrilateral. In this AQR, one second, AQR, that is this angle, AQR is equal to ANR, which is equal to 90 degrees. Why 90 degrees? Because both of them, basically, you see this is the normal, this is the normal, and normal always makes 90 degrees. So this side also it's 90 degrees, this side also it's 90 degrees. Very obvious, right? Because normal is always going to be 90 degrees to the surface. So that is equal to 90 degrees. Directly I can say that is equal to 90 degrees. Awesome. Now, QAR, that is QAR, this angle, QAR plus QNR, that is these two angles, is equal to 180 degrees. Why 180 degrees? In a quadrilateral, all four sides, the sum of all four sides is 360 degrees. We've seen that. If both these sides are 90 degrees, then obviously those two should be equal to 180 degrees. Very simple. Those two are 90 degrees. So these two should be 180 degrees because in total, if you sum it all up, you'll get as 360 degrees itself. All right. Now, this angle QAR, I'll just name this as angle A, which is nothing but the angle of prism. All right. That is nothing but the angle of prism. Now, QNR is what? QNR, this angle is this angle is equal to 180 minus A. I'm just substituting in place of QAR, I'll just substitute it as A and rearrange the equation to get me QNR. So QNR is equal to 180 minus A. Very simple. Now, in QNR, this angle, that is QNR, what is A? We have seen this before. What is basically like from this from the previous equation, what is A? This is what is this is what we got before, I plus I dash minus R plus R dash. So yeah guys, but in QNR is what? QNR is this triangle, this tiny little triangle QNR. Now this is basically 180 minus r plus r, because obviously this angle QNR, which this angle is equal to the total is 180. So 180, the total, the three angles put together is 180 degrees. So 180 minus r plus r dash would basically give me QNR. So I followed two equations. One is QNR is equal to 180 minus A, and one more equation, QNR is equal to 180 minus R plus R dash. Now, when you equate both the equation, what you're going to get is basically R plus R dash is equal to A. So what will happen? 180 gets cancelled, QNR and QNR gets cancelled, and what you are left with is basically A is equal to R plus R dash. Now, what I'm going to do is that I'm going to substitute this value, that is A is equal to R plus R dash is equal to A, in this equation. So in place of I plus I dash minus R plus R dash, so I'm going to put this in place of R plus R dash, I'm going to put as A. So what I'm going to get is basically delta is equal to I plus I dash minus A is what I'm going to get. So rearrange the equation. What you'll get, if you take the A term to the other side, you'll get it as I plus I dash is equal to delta plus A. That's all, people. I know that I did not write intro. The reason because I did not write intro is because, guys, I did not have enough space to do so. So I hope you guys understood this. I've explained it step by step. Whichever part you did not understand, watch it once again and try to understand that by then. If there's any more doubts regarding this, let me know in the comment section below, and I'll try to make it more simpler as much as I possibly can. I don't think I can make it any simpler than this, but at least I can try to cut down a couple of steps and make you guys understand it a little. But yes, guys, this is how it goes, step by step, how you find out this equation I plus I dash is equal to A plus delta, where I is nothing but the angle of incidence, I dash is angle of emergent or emergent angle, and A is nothing but angle of the prism, and delta here is nothing but the angle of deviation. As simple as that. Alright, now to talk about what are the factors affecting deviation. What are the different factors that affects deviation? First of all is the angle of incidence. Second, the material of prism. Thirdly, the angle of prism, and also the color or wavelength of light that is used. All these four factors affect the angle of deviation. The first one, guys, the incident ray. This is a simple graph, a simple curve that basically on y-axis it shows the angle of deviation, and on the x-axis you have the incident ray. Now here's what is the thing, guys. If you look at the curve, you can very clearly notice that as the angle of incidence becomes almost equal to the angle of emergent, the delta, that is the angle of deviation, actually reduces. So angle of deviation, when it becomes a minimum when the angle of incidence is almost equal to angle of emergence. At that time the angle of deviation becomes very, very minimum. So if you were to put this in the first equation, that is in place of I dash, if I put it as I, so if you remember the equation, I plus I dash is equal to A plus delta. So what will it be? I plus I is equal to A plus delta. So you'll get as 2I is equal to A plus delta. So you can say that delta is equal to A plus 2I, or A minus 2I, or 2I minus A. Let's just rearrange the equation. Sorry about the sign. Just take the A to the other side so that you can keep that positive. So you'll get as 2I minus take it to the other side, you'll get as 2I minus A. So that's how you basically get it, guys. So the deviation is minimum when angle of emergence is almost equal to the angle of incidence. That's when you get the minimum angle of deviation. Now to talk about the material of prism. Here's the thing, guys. Higher is the refractive index, the greater is the deviation, because higher refractive index means the slower the light would be, so greater the deviation inside the prism, and lower the refractive index, the lesser would be the deviation. For example, if you look at this example, for example, flint glass and crown glass, the refractive index of flint is greater than crown. So if you see this, flint has a greater angle of deviation compared to crown glass, where the angle of deviation is far more minimum. So it also depends on the the material as well. Higher the refractive index, greater would be the deviation as well. The next factor that it depends on is nothing but the angle of prism. The greater the angle of prism, the greater would be the deviation as well. So just to give you an idea, this is what it is, guys. So imagine the if you look at this, you see this as the angle of incidence is also changing. As the angle of incidence, this is for incident ray actually. As the angle of incidence is changing, you see that at 45 degrees the angle of deviation is also increasing. But yes guys, to give you an idea, yes, as the angle of our prism, or the angle of prism increases, the angle of deviation also increases. But this one is actually for incident ray, so it's a completely different picture. But yeah, this will give you an idea of how it is like. So if you increase the angle of incidence, the deviation also increases. But again, if it's very the angle of incidence, if it's almost equal to the angle of emergent, then the deviation is bare minimum. All right, apart from this guys, one more thing is nothing but the wavelength of light. The refractive index decreases with the increase in wavelength. I've told you this already, because if the wavelength of the light increases, then the speed of light is also increasing, so the refractive index is actually decreasing. So if that is the case, what you have to understand is guys, red would be the one with the least deviation, or the least you can say the deviation itself, and violet would be the one with the greatest deviation. So the angle of deviation of red is bare minimum compared to violet, where it'll have a greater deviation, or the angle of deviation is going to be far more greater for that. So the refractive index of violet is greater than the refractive index of light, so the delta of violet is going to be greater than delta of red. As simple as that. Alright guys. So yeah guys, before we get into the question and answers, let me tell you something very important. Many of you guys already know about it. I am pretty sure that you guys have heard this 1,000 times already, but still guys, this is for all the new guys out there. This is something that is definitely going to help you guys in your studies ahead. So here's the thing guys, we had actually asked you what are the problems that you guys are facing during this exam time because of all the quarantine thing that is going on. So what are the problems that you guys are facing on a daily basis? And these are things that you guys came up with. One is that, sir, my doubts are not getting cleared on time. Secondly, sir, notes, how do I download the notes? I'm studying from so many different YouTube channels, but how do I download the notes? Thirdly, tests and assignments, because I don't want to directly go and sit in front of the exam and write the exam. I want to practice. So where do I get these tests and assignments to practice those things that I've studied? Fourthly, competitive exams, because yes, you're planning to give your NTSCs and KVPI and your Olympiads and stuff. So how do you practice and prepare yourself for that? And finally, the choice of your own schedule, because yes, you want to know if you can study at this particular time, and you want to know if your class is available at that time, and that is something that has been going on for a very long time. There's a conflict of our schedule. And finally, choice of your own language, because yes, language is also a very, very important thing. But here's the thing guys, all these are problems. Together with this, you would have 1,000 others, but we at Vedantu are trying our best to solve all these problems. In fact, we have been successful to solve all these problems in one shot. Inside the class, you will not just have one teacher, you will have two teachers. You'll have the master teacher, you'll also have the class teacher to help you clear your doubts as well. The master teacher would help you in understanding the concepts and stuff, and the class teacher would help you to clear your doubts. You can download all the notes and recordings of each and every session, so you don't have to miss out on anything. Even if you miss out a class, you can always watch the recordings and download the notes. You have regular tests and assignments to check where you're going wrong and what are the things that you can do to improve yourself. You will be trained for your competitive exams. Whatever competitive exams you're planning to write, you'll be trained for that as well, and you can choose your own schedule. Live classes are going on 24/7. Whenever you feel like studying, you can choose that particular teacher and study from them. And finally, choice of your own language. We are offering sessions in both English as well as in Hindi. So if you're someone who understands Hindi better, then you can choose go with the Hindi sessions. If you're someone who understands English better, then you can go with the English sessions. Now here's what you have to do guys, click on the link that is given in the description below, and these are some of the bonuses that you're going to get. Unlimited live classes, you can attend how many live classes you want. You can attend all micro courses and crash courses, performance report of whatever tests and assignments that you've taken, and you get personalized attention to make sure that you guys are on the right track. So what do you have to do? Click on the link that is given in the description below, and as soon as you click on the description, this is what you're going to get. They'll ask you which grade are you in. Is it from 1 to 12th grade? Let's say you're in 10th grade. Once you click on 10th grade, they'll ask you which board do you belong to, CBSE, ICSE or Maharashtra. Click on whichever board you belong to, and this is what you're going to get. Everything that I just told you in detail. You can pause the video and watch it if you want to. But yes guys, what you have to do is click on get subscription. Once you click on get subscription, this is what you're going to get, 1, 3 or 6. Let's say you want to try for the next 30 days and see how it works out for you. So if you want to go for the 1 month course, the base price of that is 4,000 rupees. And it's a lot, right? But don't worry about it guys, you get a primary discount on that, and the cost comes down to about 2,699 rupees. Do you guys want to save more money? definitely, right? So enter the coupon code AM Pro and get additional 500 rupees discount. And what you're going to be paying is 2,159 rupees for the whole month. Unlimited classes with India's best teachers for that price. I think it's a very reasonable cost. Moving on to the 3 months, let's say you want to go for the 3 month course. Then for the 3 month, the base price is 10,000 rupees. I know it's a lot again, but you get a primary discount on that. Essentially, what you'll be paying is 6,999 rupees. On top of that, if you want to save some more money, enter the coupon code AM Pro, get additional 1,399 rupees discount, and what you're going to be paying is 5,599 for the next 6 months. Let's say you want to go for the 6 month course. For the 6 month course, the base price is 16,000 rupees, but you get a base discount on that. You'll be paying around 11,499 rupees. On top of that, if you enter the coupon code AM Pro once again, you get additional 2,000 rupees discount, 2,299 rupees discount, and what you'll be paying is 9,199 rupees. Again, guys, this is definitely going to help you out. The link is given in the description below. Do not forget the coupon code AM Pro, and I would see you guys in the regular sessions. Utilize this opportunity that is there out there for you guys, and make the best out of it. Anyways, with that said, guys, let's solve some question and answers now. Try to get all the doubts out of our mind. Whatever we have seen so far, let's try to solve it, put into practice, and see where it gets us. Here's the first question. In refraction of light through a prism, the light ray suffers refraction only at one face of the prism, emerges out from the prism in the direction of parallel to the principal axis, parallel to the incident ray, bends at both of the surface of prism towards its base, bends at both surfaces to the prism in the prism opposite to the base. Which option do you think is the right answer? Let me know in the comment section below which of these do you think is the right answer. Let me see how many of you guys are able to give the right answers before I even give it. Be honest to yourself. There's no way to check it, but yes, be honest to yourself, guys. Anyways, the right answer to this question, guys, is option number C. It always in both the surfaces there is refraction happening, and in both the cases the ray of light after is trying to go towards the base. It is pointing towards the base, not away from the base. It is actually going towards the base. So option number C would be the right one. Second question. Angle of deviation is the angle which the dash ray makes with the direction of dash ray. Incident with the angle of prism, emergent and incident ray and the refracted ray and the emergent ray. And the answer, guys, let me know what is the answer in the comment section below. The answer is very, very simple. The angle formed between the emergent ray and the incident ray is what is your angle of deviation. There's no doubt about it. That would be the right answer. Next question. How does the angle of minimum deviation produced by a prism change with the increase in wavelength of the incident light and refracting angle of the prism? Does it increase and decrease, decrease and increase and decrease, or decrease and decrease? How does the angle of minimum deviation produced by the prism change with the increase in the wavelength of incident light and the refracting angle of prism? So the answer to this question is actually option number B. That is, it decreases with the increase, with the increase in wavelength. So if you increase the wavelength, basically the deviation is little. So the angle of deviation is going to be bare minimum over there. And as you increase the angle of prism, the angle of deviation would also increase. As simple as that. So here's the third question. A ray of light incident at an angle of incidence of 48 degrees on the prism of refracting angle of 60 degrees suffers minimum deviation. Calculate the angle of minimum deviation. You're supposed to find out what is delta over here. Your options are 52 degrees, 36 degrees, 40 degrees, and 50 degrees. It's a very simple problem. So write down the formula first, guys. Angle of minimum deviation. So if you have minimum deviation, that means basically the angle of incidence is equal to angle of emergence. So you'll get the formula as 2i minus a. So 2 into I is 48 minus 60. So that's basically 96 minus 60. So you'll get it as 36 degrees. So that is the answer, guys. It'll be option number B, which is nothing but 96 degrees. I hope you guys understood this. It's a very simple question. 2i minus a, that is delta, that is minimum deviation. MD is nothing but minimum deviation. You'll get the answer as 36 degrees. Last question for the day, guys. A ray of light suffers refraction through an equilateral prism. The deviation produced by the prism does not depend on what? The angle of light, the color of light, the material of the prism, or the size of the prism. What doesn't the deviation of the prism depend on? What does it not depend on? That is the question, guys. And the answer to this question would be definitely option number D. That is the size of the prism. It does not depend on the size. It does depend on the incident ray, the color, the wavelength of the light, definitely the material of the prism. You saw that if the refractive index is more, the deviation is going to be more, because obviously the light travels a lot more slower in that. And so yes, it depends on the material as well. But size, Definitely not. Here is your homework for today is, how does the angle of deviation depend on the refractive angle of the prism? That is your question. Let me know in the comment section below what is the answer to this one. How does the angle of deviation depend on the refractive angle of the prism? How are they both related? Let me know in the comment section below. I hope to see you guys in the next session. Thank you for joining, people. Leave a like and subscribe to the channel and be a part of the squad. Thank you for joining. Catch you guys in the next one. Stay safe and peace out, people. Bye bye. Take care.